Good afternoon and welcome to yet another extravaganza. This is number 2 of 3 on resistors and parallel. So we'll kick this one off and we'll say, well, again, you have to know the definition of being parallel. It does not mean one above the other. It means they have the same voltage and the current splits. That's what it means. Tasteful tattoo, the inside of your arm, or the other option, learn it. Now this one I want to look at, how do we find the combination of resistors? And I want to look at this equation here, 1 over R total is equal to 1 over R1 plus 1 over R2. Now that's where I'm going to stop at the minute. And just listen to the background. Warning, warning. Why do I do that? Warning, because this is where people make a mistake. Warning, remember, 1 over RT, invert it. I mean, throw it upside down like an image. Invert to find RT. I believe I've got a fan base here, isn't it? Oh well. Clown. Right. What we're going to look at here is I'm going to look at 2 resistors the same in parallel. Right. We're going to look at 2 resistors in same. There's the 2 resistors in parallel. So we're going to look at the same. So let's follow the blue spot. Current comes up here. And because they're the same, they're both 8 ohm resistors because I have made them that. The current go that way and the current will go that way. So what could I replace this 2 8 ohms in parallel to? So let's put down the formula. There's a mark for that. 1 over 8 plus 1 over 8. I suppose you should have put 1 over R total is 1 over R1 plus 1 over R2. A mark for that. Then I put the thing. Common denominator, 8. The denominator, number at the bottom. We call the one at the top. Numerator, I'm an old man, I know that. So 1 plus 1. 1 plus 1 is 2 over 8, which is known more affectionately as a quarter. Warning, warning, warning. I want RT. I don't want 1 over RT. Throw this side upside down. Throw that side upside down, so RT is equal to 4 ohms. So I can scrap that and replace it with, I can replace those 2 in parallel with 1 resistor of 4 ohms. Happy bunny? Now just have a wee look. Do you see when they're the same? You can simply have them, but only when they're the same. See, when they're the same, you can have them. Like if that was a 10 ohm and that was a 10 ohm, that would be a 5 ohm. If that was 100 ohm and that was 100 ohm, that would be a 50 ohm. You can have them, but only when they're the same. Now we're going to look at them when they're different. Now, some people find it hard to add fractions because they don't know how to find a common denominator. In other words, find a number at the bottom that's the same to both. So I'm going to look at this setup here of a 3 ohm and a 6 ohm in parallel. How do I know they're in parallel? The current splits. Follow the blue spot, look. And there. See that? Now, if you were current, what way would you go? You go up handy through the 3 ohm, it's smaller resistance. If you're Tommy tight, oh, there's nothing to beat me, I'll go around the 6 ohm. So less current, we're expecting less current in that one. But what combination, what resistor could I replace those 2 with? Well, let's look at the formula. 1 over R total is equal to 1 over R1 plus 1 over R2. There's a mark for that. See if you don't get that. Mark lost. So remember, write the equation down. That's a bit of a damp squib, that, wasn't it? Right, so let's have a look at this. 1 over r total is 1 over a third plus 1 over 6. What's the common denominator? 6. So 1/3 is the same as 2/6. Add on 1/6 is the same as 1/6. 1 over r total is equal to 3 over 6. Warning, warning. Yes, make a clean it yourself, right? Let's have a look. So r total is 6 over 3, which is 2 ohms. So I can scrap this and put in one resistor of size 2 ohms. So replace by 2 ohms. Hard to believe I get that crowd into this small room thing. Right, let's go on to the next one. Now I'm going to do, I'm living life on the edge here. I'm going to do different, but this time I'm going to do 3 resistors. If you went through some of the past papers, you would think actually that they only do 2 and they're the same, but I come across a crapper one time and I thought that, but I've now changed it. 4 ohms, 6 ohms, and 12 ohms. And there's current comes in here. How do I know they're in parallel? Look, follow the blue spot. The current splits. What way would the most current go? The answer is through the top one. Easiest, smallest resistance. What about the next one? Through the middle. And the least current would go through the 12. Yes? Now, mark for the equation. 1 over r total is equal to 1 over r1 plus 1 over r2 plus 1 over r3. Thanks. I just really appreciate that. Now, let's fill in the bits and pieces that we know. 1 over 4 plus 1 over 6 plus 1 over 12. The denominator, 1 along the bottom. What's the one that's common to all? 12. What's a quarter the same as? 3/12. 3 over 12, same as a quarter. What's a sixth the same as? 2/12 is a sixth. Plus 1/12. 1 over r total. Go to the next line. 3 and 2 is 5 and 1, 6. 6/12. You could do that in the calculator if you don't know how to do that. Right? Warning, warning, warning. RT is 12 over 6. Throw that side upside down. Throw this side upside down. 12 over 6 is known more affectionately as 2 ohms. So I can replace that with one resistor of size 2 ohms. Fair enough? I can replace these 3 resistors with one resistor of size 2 ohms. So, what I want you to do now? Well, what I want you to do now is I want you to write out that mind map and upload it to me. Fair enough? So you have to write out the mind map and upload it to me. There's 5 marks for that. It's time bound. I want it done. Thanks for listening. Toodle pip.